Hello, welcome to Miss YY channel. Today we are going to discuss chapter 4.2 Stoichiometry. So at the end of the lesson, you should be able to calculate the amount of reactant and product from a balanced chemical equation. And also the calculation will involve the reacting masses and mole, volume of gases, and also the volume and concentration solution. Stoichiometry can be defined as a quantitative relation between the number of moles of reactants and product from a balanced chemical reaction. So this is an example of a balanced chemical reaction, and from the balanced chemical reaction we can extract a few information such as 1 mole of calcium carbonate will react with 2 mole of HCl. Or 1 mole of calcium carbonate can produce 1 mole of calcium chloride. Or 1 mole of calcium carbonate can produce 1 mole of carbon dioxide. Or 2 mole of hydrochloric acid can produce 1 mole of calcium chloride. Or 2 mole of HCl can produce 1 mole of H2O. So these are the relationship between the reactants and the products. So now let's look at the calculation involved with stoichiometry. So example 1, 3-hydrochloric acid will react with 1 mole of aluminum hydroxide to produce aluminum chloride and 3 mole of water. So the question asks how many grams of aluminum hydroxide will react with 5.3 mole of hydrochloric acid. So from the balanced chemical equation, we can write down the stoichiometry relation, which is 3 mole of HCl will react with 1 mole of aluminum hydroxide. So in the questions, we are using 5.3 mole of HCl. So when we use 5.3 mole of HCl, what is the number of mole of aluminum hydroxide needed? So after you write the stoichiometry relation, so we can do the cross multiply, which is 5.3 multiplied by 1 divided by 3. So we can find the number of mole of aluminum hydroxide. So from the cross multiply, the number of mole of aluminum hydroxide is 1.767 mole. So means that when we are using 5.3 mole of HCl, I will need need to react with 1.767 mole of aluminum hydroxide. So after got the mole of aluminum hydroxide, we can find the mass by multiply with the molar mass. So the mass of aluminum hydroxide is 60.04 gram. So now second example, how to calculate the volume of carbon dioxide at STP from the 100 gram of C4H10. Okay, so from here, we have to use the number of mole to do the stoichiometry relation. So first thing, we are going to find the number of mole of the butane. So to find the number of mole, we can use the mass divided by the molar mass, and the number of mole of butane is 17.24 mole. So after we found the mole of the butane, from the balanced chemical equation, we can see 2 mole of C4H10 will produce 4 mole of carbon dioxide. So first we have to write the stoichiometry relation based on the balanced chemical equation, which is 2 mole of butane will produce 8 mole of carbon dioxide. And in the actual, we are using 100 gram, which is 17.24 mole of butane. So when we are using 17.24 mole of butane, what is the number of mole of carbon dioxide gas will produce? So we do the cross multiply, which is the number of mole of carbon dioxide is equal to 17.24 multiplied by 8 divided by 2. So the number of mole of carbon dioxide produced from 1000 gram of C4H10 is equal to 68.96 mole. So after got the mole, to find the volume, we are going to multiply by the molar volume at SDP, which is the standard temperature and pressure. So volume of carbon dioxide is equal to 68.96 multiplied by 22.4, which is equal to 1544.7 dm cube. So example number 3 is the calculation involved with the volume and concentration of solution. So you are given the molarity of HCl and the volume and molarity of sodium carbonate. So to find the volume of the HCl, okay, we need to know the mole of the HCl. So first, we are going to find the mole of sodium carbonate. So the mole of sodium carbonate, okay, as we know, molarity is equal to mole of solid over volume of solution. So to find the mole, we're going to use molarity multiplied by the volume in liter. So the mole of sodium carbonate used is 0.00318 mole. So means that in this titration, okay, we are using 0.00318 mole of sodium carbonate. And based on the balance equation, it says that 2 mole of HCl will react with 1 mole of sodium carbonate. So this is the stoichiometry relation, which 1 mole of sodium carbonate will react with 2 mole of HCl. So in the actual reaction, okay, we are using 0.00318 mole of sodium carbonate. So how much HCl it will react? So the cross multiply is the number of mole HCl is equal to 0.00318 multiplied by 2 divided by 1, and we got the number of mole HCl is equal to 6.36 times 10 to the power of -3. So it means that we got the mole of the HCl. So from the mole, we can calculate the volume based on the molarity given. So formula, molarity is number of mole divided by volume. So we substitute 0.112 into molarity, and then the mole is 6.36 times 10 to the power -3. So to find volume, we use number of mole divided by the molarity. Okay, to find volume, number of mole divided by molarity. So we got the volume is 0.05678 liter. And in the questions, the question is asking in milliliters, so multiply by 1000, which is 56.78 milliliter. So at the end of the lesson, you should know how to relate the stoichiometry relation between the number of mole of reactants and product from a balanced chemical equation. So thank you for watching. Please like, share and subscribe if you like my videos.